I know that you've seen acids before because we've named them, and I know that you know that acids typically have pH less than 7. But the definition of an acid is actually a little more sophisticated than that. In fact, there's not just one definition of an acid. There are many, many definitions, but we're going to limit ourselves to 3. The oldest and most classic definition is for an Arrhenius acid, named after Svante Arrhenius, who first came up with the theory. An acid, like an Arrhenius acid, has to produce hydronium ions in aqueous solution. So in the example, acetic acid in water produces hydronium ions. We may see hydrogen ions as we work through problems as well. The problem is that that was not general enough. So a more general definition is a Bronsted-Lowry acid. That's where we're going to spend most of our time. Bronsted-Lowry acids are proton donors. So that works for Arrhenius acid, and it works for the next 2 examples. HCl donating its hydrogen to NH3, making NH4+, or acetic acid donating its hydrogen to NH3, making NH4+. You might not recognize this first one as an acid-base reaction because there's no aqueous solutions and we don't actually see the ions. We only see the ionic solid that remains. As chemists got more sophisticated, they realized that even the Bronsted-Lowry was not general enough. So G.N. Lewis came up with his definition. He did a lot of work with electron dots, the Lewis dot structures. So he said that a Lewis acid is something that accepts a pair of electrons from a Lewis base. So in this case, BF3 is our acid, and those 2 electrons get added to it. So it accepts an electron pair. So those are the 3 major types we're going to focus on, but almost all of our time is going to be spent with the Bronsted-Lowry acid. We can divide them into 2 categories, strong and weak. And strong and weak correspond to their behavior as electrolytes. Strong acids break up 100% in solution. Weak acids, only a small fraction of them. And so a strong acid would have a much stronger ability to have a current flow than a weak acid at the same concentration. We're going to do lots of reactions with those, so stay tuned. You need to know the 6 strong acids. You just have to memorize them. HCl, HBr, HI. Those are the binary acids, binary meaning 2. And the oxy acids, sulfuric, nitric, and perchloric. Every other acid that we will deal with is weak. So that's just a brief introduction to acids. We're going to use those as we write net ionic equations.